Hi, welcome to Marker Board Videos. Today's video is about thermodynamics. And thermodynamics is another one of those big physics words that just means the study of heat and how heat transfers to mechanical energy. And there are three laws. Just like we had Newton's three laws of motion, there are three laws of thermodynamics. And you're going to need to know what each of them are and to be able to identify examples of each. So please make sure you really study these. Very important. Let's start with the first law of thermodynamics. First law of thermodynamics is also known as the law of conservation of energy, which we've been talking about for weeks now. Energy cannot be created or destroyed, but it can change forms. If we could take all of the energy in the whole universe and add it up, whatever that total is, it's always going to be that total. It's never going to change. Yes, it may change from mechanical to sound, or from heat to light, or any of a number of things. It can change forms, but every time we stopped and added it all up, you'd see it was exactly the same, that it never ever changes. That sum has to be the same. So when we have a small system, like we demonstrated with the Newton's cradle with the balls going back and forth, or like we did with a guy coming out of the building and his different potential and kinetic energy on the way down, same thing. That sum is going to be the same, and that's what the first law of thermodynamics says. The second law of thermodynamics you live probably every day. I know that I do. It has to do with a thing called entropy. Entropy. And entropy just means that things always want to go from orderly to disorderly in the universe. Things want to become more chaotic and more messed up. Think about your room. You clean your bedroom. Everything is perfect. But if you're anything like me, I'm going to have to clean it again because things want to be disordered. They don't want to be orderly. And so your room goes from clean and orderly to disordered, and then you work to make it clean and orderly again. But you know that eventually it's going to be disordered and you're going to have to work on that again. That's what entropy is, which is the second law of thermodynamics, and it also explains why things flow from hot to cold, because they want to become, everything wants to be disordered, and in cold it's more orderly, but in order to be disorder it needs to increase its temperature. So cold, to increase, when it increases its temperature, it increases its kinetic energy, it increases its random motion, it becomes less orderly and more chaotic, which is exactly what entropy says. Energy is going to transform into less usable forms. As far as we know, it's going to change into less usable forms, which is why you can never have a machine that's 100% efficient. It's always got to be less than 100% efficiency, because it's going to go towards a disorder. It's going to go towards a less usable form. That's two laws. Now the third law is Kelvin. It's absolute zero. The third law of thermodynamics says that all molecular movement is going to cease or stop at absolute zero. So at 0 degrees Kelvin, or 0 degrees absolute zero rather, there's absolutely no movement of molecules at all. None. Zero. No movement. And that's called absolute zero, or 0 degrees on the Kelvin scale. It is also negative 273 degrees Celsius. Really cold. No motion of molecules. At this point, we say no system can ever reach absolute zero. We've gotten really, really, really close, but we've never reached it. And scientists are saying that that's kind of like a limit, that we will never reach absolute zero. But I want to caution you, because science is continually growing and changing, so this is our best guess as to what's going on. As far as you're concerned, no system can reach absolute zero. But I'm adding a caveat to say that in the future, we don't know if what we know now is going to prove to be exactly true, and maybe we can reach absolute zero. I don't think so. My scientific background is telling me we can't. Scientists much wiser and more experienced than I are telling me we can't. So we're going to say no system can reach absolute zero. So remember, three laws of thermodynamics. Make sure you know definitions for all three of them and examples.